Good day everyone, I'm Austin Michael Dakis from AMT 3-4 and today I will demonstrate our experiment titled Popcan Hero Engine. So let's start. Our materials are soda can, marker for marking the holes, medium size common nail for punching a hole in the can, a thread, a ruler for measuring the length of the thread, scissor for cutting the thread, and we also need pitcher of water, medium sized tub, and a cleaning cloth for cleanup. But first, we use our personal protective equipment for safety. Step 1, use our marker for marking the holes. Step 2, use our medium-sized common nail to punch the hole in the can. With the nail still inserted, push the upper end of the nail to the side to bend the hole, approximately 90 degrees. Step 3, in order to measure the thread, we use ruler as a substitute for meter stick. Measure the thread 40 to 50 cm. Use scissor for cutting the thread. Step 4, get your soda can and bend the opening lever up straight. Then tie up your thread. These are used for center of the mass or center of gravity to balance the force acting on the can. Now that we are ready, this experiment demonstrates Newton's third law of motion by using the force of falling water interacts the soda pop can, causing it to spin, and to experiment with different ways of increasing the spin of the can. And in the last part, we use our pitcher of water and put it inside the soda pop can. As you can see, the can is spinning because of the force of falling water interacts the soda pop can. This explains the third law of motion, which is called interaction. For this experiment, we made 3 different kinds of can with 4 holes, 6 holes, and 8 holes to identify and improve the Pop Hero engine in order to give you the best result. Now we will fill up the soda can with 4 holes and see the result. Now we will fill up the soda can with 6 holes and see the result. And lastly, we will fill up the soda pop can with 8 holes and see the result. After we are done with our experiment, we can now compare these different kinds of can with 4 holes, 6 holes, and 8 holes. For this can with 4 holes, spin slowly and loses water slowly. For this can with 6 holes, spin faster than this can with 4 holes and loses water continuously. For this can with 8 holes, spin the fastest than these 2 cans and loses water rapidly. And now, let's answer the question in the Hero Pop engine discussion. Number 1. Why did the cans begin spinning when water poured out of the holes? There are a combination of factors that contributes to the force that causes the cans to rotate. The most important is the force of gravity. It attracts the water in the can and causes it to stream out the holes. The shape of the hole directs the water streams. The diameter of the hole determines how fast the water streams out. When the water is poured out into the cans and then withdrawn, gravitational force the water through the angled holes, creating streams that run either clockwise or counterclockwise. An action force is produced by the streams, which is occupied by a reaction force, and the can begin to spin in the opposite direction. Second question, what was the action and what was the reaction? Pop Hero engine is a great example of Newton's third law of motion. The action in the experiment is the force created by the falling water because of the gravity, while the reaction is the spinning of the soda pop can because of the streams coming from the holes. According to Newton's third law of motion, every action has an equal and opposite reaction, which is law of interaction. And lastly, did all the cans spin equally well? Why or why not? Yes, because of the Newton's third law of motion, which the force has equal and opposite reaction, causing it to spin when the water is poured out into the can. The can with 4 holes spin slowly, causing the water to lose slowly. The can with 6 holes faster than the can with 4 holes, causing the water to lose continuously. And lastly, the can with 8 holes spins the fastest than the 2 cans, causing the water to lose rapidly. Now, thank you for listening, keep safe, and have a great day.